Hi, this is our final project.
We did our project on the 1987 Indonesian contraceptives data, and we discovered that the level of a woman's education could be associated with the number of children she has, based off a slight linear relationship in the scatter plots we explored.
We performed an A-B test because we wanted to compare a numerical variable to a categorical variable with two groups. In this test, we compared a woman's education level, either 1 or 4, and the number of children she has. Our null hypothesis is that there is no difference in the average number of children based on education. And our alternative hypothesis is that there's a difference in the average number of children between women with education level 1 and women with education level 4.
Our quantitative plots on the left are on the left, and these histograms clearly show that there is a distribution, that the distribution of the number of children of the participants is different from at each education level, with the most significant difference being between levels 1 and 4. This is significant because it suggests there may be a correlation between the average number of children a woman has and her education level in Indonesia.
This qualitative plot on the right is a bar graph that shows the average number of children of the participants in each education level, which relates to the quantitative plots on the left, as it is the average number of children taken from each of the histograms. This plot suggested that there was a correlation between the average number of children and education level of a participant, which we then used as variables for our A-B test. This aggregated data table on the left groups the participants by the categorical variable of wife education 1, 2, 3, or 4, and gives the average number of children for the participants in each education level, as well as the counts. We decided to include the counts for each education level, as having a disproportionate number in each level is a limitation, which we'll expand on in our limitation slide.
On the right, you can see our joined table, and this data shows that the average number of children per household for the husband levels of education 1 through 4. This could be useful in further analysis.
So creating a histogram, the histogram that you can see on the right, of our simulated test statistics from our A-B test, we found that the range of the absolute value of the differences from shuffled groups was 0 to 0.8, meaning our observed test statistic, which we found to be 1.436, was not even within the range of the simulated test statistics. We completed the p-value and found that it was 0, allowing us to strongly reject the null hypothesis that there is no difference between the average number of children of the participants in the two education levels 1 and 4.
Moving on to our predictor, we used the prediction method of the k nearest neighbors, and we wanted to be able to predict a woman's education level, 1 or 4, based off her number of children. Our classifier uses rows in the test set to predict an education level based off of the number of children a woman has. This classifier was able to predict with 81% accuracy the education level, 1 or 4, given the number of children a woman has.
From our A-B test, we can reject the null hypothesis since our p-value that we calculated was 0.
And this strongly supports the alternative hypothesis that there is a difference between the number of children a woman has at education level 1 and versus education level 4. And this suggests that women with a higher education have less children and vice versa.
One major limitation with our A-B test was that we found a disproportionate amount of people in the education levels, as we showed in a few slides back with the counts, which would affect the accuracy of the averages taken to determine our sample test statistics by the law of averages.
Additionally, this makes it so our classifier has more access to data from education level 4 women, and thus can predict those women's education level more accurately, because our training set has access to more data for women with education level 4 than education level 1.
Thank you.